In this video, I'm going to go over number 6 on our calculus practice test 1. A rock is thrown from Navajo Bridge, which is 1936 feet above the Colorado River near Page, Arizona. The rock's height, the height h, above the river, t seconds after being released, is given by this height function. So look, they gave us the height function. Okay, what are we going to do with this? Let's see what they want. The first question says, find the rock's height. Hey, they gave us the height function. They want you to find the height. Let's use it. H of, and at what second did they want? They said t equals 2.5 seconds. All right, 2.5 seconds. I'm going to plug in 2.5 into h. And I'm going to my calculator somewhere online. Looks like my email is open, so I may just have to open another tab. All right, hold on. I'm going to what was I going to search? Oh, Desmos Scientific Calculator. Okay, let's type in 1936 minus 16 times 2.5 squared. That comes out to be 1836. So, going back to my iPad or to the problem, 1836 is the answer. 1836, and this is the height, and I think the unit was in feet, right? Oh, yes, it is right here. Right there. So I put the unit. Must be a, I don't know, I can't really see how fast this is falling, but that's it. We found the height after 2.5 seconds. Now let's look at the next question. This is asking us to find the rock's velocity. Now remember, velocity is the first derivative of the distance function or the height function. So what we will do is we will need to find the derivative of h of t. Okay, so derivative of a constant is 0, so that goes to 0. Derivative of negative 16t squared is negative 32 t to the first power. So we found the velocity function, which is the first derivative of our distance function or the height function. So let's now plug in 2.5 into this function. So let's do negative 32 times 2.5. All right, I think I can use my baby little calculator to handle that. It's just my iPad always takes the entire page. Okay, let me enter negative 32. I really don't know how to type in negative in this calculator. Times 2.5. So negative 50. No way, that's not right. Are you kidding me? 32 times 2.5 is not 50. Silly. I don't even trust this anymore. I don't trust you. Let me go to my Desmos. Negative 32 times 2.5. This is, guys, why I'm telling you to please show work so that if something happens on your calculator, I know you typed the right thing. Okay, so the answer is negative 80. Hold on, let me write the answer down. Negative 80. And let's put the right unit. This is velocity. So negative 80 feet per second. That's how fast is this falling. And it's negative because the distance from this rock to the ground or the river is getting smaller and smaller as the rock gets closer and closer to the water, right? All right, let's do the next one. Find the rock's acceleration. Now remember, acceleration is how fast the speed or the velocity is changing. In other words, the second derivative of the height function. So let's find the derivative of this height function. What is the derivative of negative 32t? It's just negative 32. So guess what? What we just found out is that acceleration is constant, is always negative 32. So if they ask us to find acceleration at 2.5 seconds, it's simply negative 32 feet per second squared. And that is the unit for acceleration. Okay, I have a feeling you are okay with the first three, but it may be the last part that you had a question on. So let's talk about the last one. It says the velocity at which the rock hits the water. Let me underline this part. At which rock hits the water. That means, for the rock to hit the water, the distance between the rock and the water has to be 0, right? To hit the water, it has to touch the water. So this is what you will solve first. Find the time when the height is equal to 0. Okay? The height from the rock, a height from the water to the rock. Like here's my water and here's my rock. They need to touch. So the height is 0. Make sense? So let me go ahead and graph the height function from above. The height function is 1936 minus 16t squared equals 0. I'm going to solve this equation, okay? So first, I'll just subtract 1936 from both sides, and I'll get negative 1936. I'm going to divide both sides by negative 16, and I'll get t squared equals, I need a calculator, negative 1936 divided by negative 16 equals 121. Very nice number. 121. And technically, guys, as we think about taking the square root, you're right. Hold on. I wonder if you can see my screen. Okay. As you take the square root of both sides, it is t equals plus or minus 11, because square root of 121 is 11. But think about this. Can we have negative 11 seconds? No, it has to be positive 11 seconds, not going back in time. So what you're now going to do is, we know t is 11. They want you to find the velocity. Find the velocity when t is 11. So let's plug in 11 into the velocity function. V of t from part B is negative 32t. If I plug in 11 in here, I will need to do negative 32 times 11. So I need my calculator again. Negative 32 times 11 equals negative 352. Negative 352, and the unit is feet per second. So when it hits that water, it's traveling very fast. Boom. Okay, so that is how you will do number 6. This is the only question that I got an email about so far. So if you guys are working on this practice, oh, whoopsie, let me see if you can see my screen. If you guys are working on your practice test and come up with any part that doesn't make sense by just reading the work that I put, please email me. I'll be happy to go over them in a short video for you, okay?